Okay, today is FYI, so today we're going to look at the implicit functions. Okay, if we're talking about implicit functions, okay, so we're going to look at two different formula. The first formula that is when you are given equations that involve the variable x, y only. For instance, that is something like that. Okay, what you have to do is you have to rearrange this, okay, such that it's in the form of function f equal to 0. Okay, once you have that, the next thing is you can find the dy dx by using this. Okay, this formula. Use this formula. Okay, if you are given an equations that is involved with three variable x, y, z. Okay, so equal to something. Okay, equal to some value. So the things that you have to do is again same. That is, you have to rearrange it just that it's equal to 0, something like that. And then you can find your partial derivative by using this formula. Okay, so why don't we directly look at the example, then you understand that. Okay, so let's look at the first example. So allow me to push up a bit on this. Okay, let's look at the first example. Let's look at this one. Okay, so example 1. So example 1, we have x cubed plus y cubed minus 2x squared y equal to 100. The first thing you have to do is rearrange it such that this equation is equal to 0. Just have to bring this one to in front. You will have a minus 100. Okay, and let it equal to 0. Once you have let it equal to 0, what you have to do is, okay, now you can obtain your function capital F that is in capital F that is contains the variable x, y, z. That is this x cubed plus y cubed minus 2x squared y minus 100. That is whatever that we have arranged this one. That is this. Alright, once you have obtained your function f, so let's look at the formula again. The formula says what? The formula says that, okay, first of all, you need to find your fx. Okay, your fx is the derivative. Okay, we partial differentiate with respect to the x. Okay, and the next will be your fy. We're going to do a partial differentiate. Okay, so partial differentiations with respect to y. Okay, so let's do it. Okay, so once we have done with that too, so we can substitute into this formula. So we'll begin with this one first. Okay, so okay, if we look at that, okay, so we're going to have the fx first. Fx means that you're going to treat the y as constant. So this is a thing that we have done many times. Okay, so we're going to differentiate this. This is actually give you 3x squared, and this is constant, so we have a 0. So 0, you don't have to write it out. Okay, and we have minus 2x squared. X squared you can differentiate, but y is a constant, so you differentiate the x squared, so we have the minus 4x y. Alright, and minus 100, that is give you a 0, so we don't write the 0. Okay, so that is your fx. Okay, how about your fy? Okay, so same thing, we'll do the same thing. So we'll do the fy. Push it out a bit on this. Okay, if we're talking about fy, so that is again same thing, but before this, okay, I will treat the x as constant. So refer to this function, and now, okay, so this is a constant, so you differentiate constant, you have a 0, and this is the thing that you're going to differentiate, so you differentiate, you will have 3y squared. And same thing happened to here. 2 is constant, x is constant, but y you can differentiate. So you differentiate the y, you have 1. So multiply with those constants, so you have 2x squared. And how about this is actually added with 0. So that is our fy. Okay, so now we are looking for dy dx. Okay, so according to that formula, we should always have the negative. okay, and we have f first, okay, we will always begin with the f, okay, so this is x, so we write x first, and then we have f y here, divided, okay, so basically it's actually very easy to memorize the formula, so you just have to create the sequence of the alphabet, right? Okay, so now, okay, what you have to do is you have to do the substitution. So let's just do the substitution. You will have minus. Okay, in order to avoid a mistake when you substitute, so make sure you put a bracket for the fx. So you have 3x squared minus 4xy here. Okay, and then how about down here? Down here we have 3y squared minus 2x squared. Okay, again, you can multiply the minus inside. So you multiply the minus inside, you have minus 3 here. And multiply here, you will have positive 4. So we will try to write the positive first. So you have positive 4xy, then followed by minus 3x squared. Alright, so that is the result for the first example. Okay, let's also get the second example. Alright, okay, so this is the second example, okay? So we repeat the same thing, so you have to rearrange this just that you have an equal to 0, an equation that is equal to 0. So we have x cubed plus y cubed plus z cubed plus 6xy z minus 1 equal to 0. Okay, that is very easy, right? Okay, so once you have that equal to 0, now you can obtain your capital function f. Okay, capital function f. Okay, so you have x, y, and until z because you have 3 variables here. Okay, so once you have that equal to 0, just remember we're just interested on those equations that you have rearranged. That is this. So this one will be your function f. Alright, okay. So once we have obtained the function f, so they ask you to find the partial derivative with respect to x and with respect to y at the first order. Okay, no matter how, the first thing that you have to find is the fx, fy, and fz, right? Okay, so fx. Okay, fx means that we're going to treat the y and z as constant. Now you have 3 variables, remember? So when you have 3 variables, okay, so you have to consider all of them together. Okay, so when you differentiate with respect to x, the y and z will be constant. Okay, so let's just differentiate now. If you differentiate this, you will have 3x squared, and this is constant, so constant we have a 0. Okay, this is also constant, this is a 0. Okay, and then in here, you differentiate x, but we have a constant 6, y, z are constant too. Okay, so differentiate x, we got 1. So the constant remaining is 1 multiplied with a constant, so you will have 6x, sorry, the constant is actually y, right? Okay, the constant is actually y, we differentiate to x. Okay, so we have y, z. Okay, so and then this is a constant, so you have 0. Okay, so let's just go for the next. You have the f y. So if you're talking about fy, so you're treating the x and z as constant, as in z as constant. Just refer back to this. If this is constant, so there's 0. This one we're going to differentiate, so we have 3y squared. Okay. This one is a constant, so it will be 0. And we differentiate y, these two are constant. We differentiate y, so you will have 2x z. Okay, so this is 0. Alright, okay, now the next will be fz. So fz, so we're going to treat x, y as constant, x, y as constant. So Now, this is your constant, this is 0, this constant is 0, and this one will differentiate, so you have 3z squared. Okay, differentiate this. So if we differentiate this, we have 6xy, and it is 0. Okay, so done for the first step. Okay. Second step, that is we look for the partial. The partial, that is very simple. Okay, so according to the formula that is, okay, del z del x. Remember, every time we have to put a minus in front. Okay, so and then we have capital function. Okay, so just look at the sequence. Down here is the x, so we put the x. Okay, at the top is the z, so we have f z. Okay, so it is like, okay. Alright, okay, and do the substitution. To do the substitution, we will have minus and put a bracket. Okay, x is this one, so we have 3x squared plus 6yz divided by z, that is 3z squared plus 6x squared. Okay. Okay. Let me put it out. Okay. So you can see that basically we can factor out some number, okay, from above and from bottom. Okay, so the number that you can factor out is actually 3. Okay, so you can factor out 3 from here. So we have minus 3 here. So our remaining of x squared plus 2yz, okay, divided by same thing, you can factor out the 3. So if I factor out the 3, I will have x squared plus 6 as a plus 2. Plus 2x1. Okay? And the 3 and 3 you can cancel out. And remaining we will have minus x squared plus 2yz divided by z squared plus 2xz. Okay? So that is for partial derivative. Okay, we differentiate with respect to the x. Okay, let's just differentiate with respect to y, and the formula will be minus. Okay, it always minus and minus f. Okay, fy is y, right? So fy, okay, divided by f z. All right, okay. So we have y here. And we have z here, right? Okay, and to do the substitution is usual. Okay, so I will push it out a bit on this. Okay, so minus fy, that is 3y squared plus 6xz divided by 3z squared plus 6xy. Again, so you can factor out the 3. So let's just factor out the 3 from here. So we have minus 3y squared plus 2xz and minus factor out 3 also. So we have z squared plus 2xy and cancel out the 3. Cancel out the 3. So then you will have the answer. Okay, so the answer is basically this. Alright, okay, so that is the answer for example 2. Okay, let's just look at the example on the implicit. Okay, so that is a bit related to our calculus 1. Okay, so again, so you have an equations. So you're going to use your implicit that you have done just now. Okay, and we have to find the equation of tangent. No matter how, okay, first of all, rearrange this thing such that you have an equation equal to 0. So rearrange this. Okay, so when you rearrange that, okay, so again, let's copy back the question. So you will have given that is this one. Yeah, place it here. Okay, so now you're given this. So rearrange it. Okay, remember when you rearrange it, you will have y cubed. Okay, minus 6x squared plus x cubed plus 1. So that is equal to 0. Okay, once you have that, okay, next thing is this one is basically your function f. Okay, that function f is only contained the variable of x and y only. So we have this. Alright, okay, done. Okay, I'm going to repeat the same process. You're going to find fx first. Fx means that you treat the y as constant. Okay, if you treat the y as constant, so means that the constant is 0. This is constant, so you differentiate, so you have minus 6y, and differentiate this, you have 3x squared. So this constant is 0. Okay, and followed by fy. So fy, so treating x as constant. X as constant. Okay, so again, you're going to refer here. So differentiate this, you have 3y squared. Differentiate this, you have 6x. Differentiate this, you have 0. Differentiate this, you have 0. So that is our fy. Okay, and refer back to the formula. Okay, so the formula that asks us to find dy dx is the same as the first example. So your formula that is minus f x first, then followed by f y, right? So just flip this sequence, flip the sequence. Alright, okay, and do the substitution as example. Let me push it up a bit. Okay, on this one. Okay, so let's just do the substitution. If we do the substitution, we have minus. Okay, minus 6y plus 3x squared over with 3y squared minus 6x. You can multiply the minus inside. If you multiply the minus inside, you have 6y minus 3x squared over with 3y squared minus 6x. Okay, the same thing in here, you can factorize out. You can factorize out the 3, factorize out the 3 from here. So you have 3, and we have 2y minus x squared. And in the same thing, you factor out, you have 3 here, so you have y squared minus 2x. Alright, so the 3 and 3 you can cancel out. 3 and 3 you can cancel out. When you have cancelled out, you may obtain your dy dx. Your dy dx is actually 2y minus x squared over with y squared minus 2 is x here. Okay, so we have 2x. Okay, so that is dy dx. That is what we did in the first example. So we stopped there in the first example. But this question is asking for the equation of tangent. If you're talking about equation of tangent, so you need to find the gradient of the slope first. Okay, so in order to find the gradient of the slope, so you need the point, the coordinates. The coordinates that given is 1, 2. Okay, at 1, 2. Okay, so to find the slope. Okay, or the gradient. Okay, the gradient of the slope, you can get it from the dy dx by doing the substitution. Okay, by doing the substitution, we have 2. Okay, and let's look at your y. What is your y here? Your y here is actually 2. Okay, minus v x squared. What is your x here? Your x here is actually 1. Your x here is actually 1, so it's just 1 here and square. Right? Okay, so same thing. Okay, happens to here. So we have y is 2, so 2 square minus with 2 multiply with your x is actually 1. Alright, okay, simplify by using your calculator. So this is actually give us 3 and this is actually 2. So we obtain our slope, our gradient as 3 over 2. And then, okay, we continue our step to find the equation of tangent. Equation of tangent. So equation of tangent, that is very direct. So what you need is actually the slope. Okay, so you're going to sub the slope, that is 3 over 2. And the coordinate that is 1, 2 into your y equal to mx plus c. Y equal to mx plus c. Okay, so y. Okay, what is your y? So your y is actually, this is your x value, this is your y value. So your x is actually 2. Your m is 3 over 2. Your x is actually 1 plus c. So rearrange it, you obtain your c as 1 over 2 Okay, once you have your c as 1 over 2, now you can find out what is your equation of tangent. So again, we're going to do the substitution. So you're going to subtract your m equal to 3 over 2 and your c equal to 1 over 2 into the y equal to mx plus y equal to mx plus c again. So it's 3 over 2x plus 1 over 2. So this one is your equation of tangent. Equation of tangent. So done. Okay. Okay, so that is the solution for the example 3.